Okay, ocean acidification, an interactive Google spreadsheet. To get the spreadsheet, if you go to this shortened bit.ly league/Excel, it's cursor down the page, you'll find this. The copy that you open is uneditable. However, if you go to File, make a copy, put it into your Google Drive, and students would have to do that as well. The interactive features that you get to play with are over here on the left-hand side. Yellow cells are places where you can put or change numbers if there's a number in there. Somewhere there'll be a response. If there's a blue cell, it's a cell not to type in because there's a formula in there. Added information comes in the form of notes that have the little black triangle on the corner, and you cursor over, you can see them. You'll also see checkboxes that do something, could bring up an answer, could turn a line on and off of a graph. There's a whole bunch of features. Good way to do an on and off switch. Okay, this starts out by having students look at some data plotted for Hawaii, where we are plotting three things. We were plotting the atmospheric carbon dioxide in blue, the aqueous carbon dioxide in seawater, and the responding pH that's dropping over time. There are a variety of questions here given in purple for students to handle and get involved with data. If they need to play with pH or hydrogen ion changes to remind themselves what's happening, that's also on the side of the sheet there. The chemical concepts that are involved are simple. General chemistry concepts for sure. One is Henry's law, the gas dissolving into a medium, in this case seawater, and the dissociation of carbonic acid or dissolved carbon dioxide into the bicarbonate ion and hydrogen ion. Just to refresh what's going on, there's the first and second step of carbonic acid to bicarbonate or hydrogen carbonate and the carbonate ion, remind them of charge and things like that. They can also play with geometry if they would like. We now want to look at this dissociation. If you're in first semester chemistry, you may want to use a simple bar graph, whereas if we change the pH here, we'll see the distribution change. And you can see as the pH rises, you get more bicarbonate, much less carbonic acid, and carbonate kind of starts to sneak in. But I think a better way to do this, especially with second semester students, is to use a fractional distribution diagram, since the carbonic acid, bicarbonate ion, and carbonate ion have to add in a materials balanced to 1 or 100%. We can look at this. We can change the pH. We can get salinity in to see the effect of what it does to the dissociation, and it shifts it by changing. So now we've moved over. If we look at pH 3, we're still dominated by carbonic acid. If we change that to 5, we're now getting bicarbonate ion. If we go to 7, we will now dominate bicarbonate ion, a little bit of carbonic acid. If we go to 8, which is about where seawater is, we're a little less bicarbonate and more carbonate ion. And so they can look at how the distribution changes. This is a diagram I would introduce, not this one. I'd use another generic, probably monoprotic one to get them started. And there's some questions on here. They then finish this up by plotting some actual data for the Canary Islands and Bermuda. And I've got a handful of references if you need a little bit more information. Sorry it was so fast. I didn't realize that my nice favorite screenshot recording thing dropped to a 5-minute video. But I guess I made it. Thanks. And any questions, give me an email. You can, if you get to this Excel page, you can find my email on my homepage. Thanks.